Okay, guys, we are looking at the performance parameter of phase control rectifier. Now, why these performance parameters are important? Because we can find out the efficiency or the accuracy, or in general, we can say we can judge the performance of particular power electronic circuit with the help of certain parameters, right? Based on different parameters, we can analyze how your circuit is behaving. We can find out the functional behavior of the particular circuit with the help of different parameters, right? So we, in short, we can say that we can judge the performance of the circuit based on different parameters. That parameters can be anything, right? And therefore these are known as performance parameters of control rectifiers, phase control rectifier, or we can say we are looking for performance parameters of converter. Okay, so we'll see one by one which performance parameters are there. The first performance parameter is output DC power. Okay, so whatever DC power we are getting from the converter circuit, that would be the first performance parameter. We all are aware that power is simply the multiplication of voltage and current, right? So the first performance parameter is average DC output power, which is represented as PDC, which is equal to VDC into IDC, right? This VDC will be the output voltage and this IDC will be the output current. And if we simply multiply both these quantities, output voltage and output current, obviously the output voltage and output current will be DC, right? And if we do this, then definitely we are getting this PDC, which is nothing but the DC power which is provided by that particular converter. That converter may be single phase converter, or that converter may be three phase converter. Okay, so the first performance parameter is output DC power, which is PDC is equal to VDC into IDC. Okay, the next performance parameter is efficiency of rectification. Next performance parameter is efficiency of rectification, or sometimes it is also called as a rectification ratio. Okay, we all are aware that rectification is nothing but the conversion of AC into DC, right? So if we take the rectified output against the applied power initially, which will be AC, then we are getting the percentage of efficiency, which is represented as eta, is equal to output power divided by input power, PODC divided by POAC into 100%, right? What is PODC? This will be output power. What is POAC? It will be input power. And if we take a ratio of PODC to POAC, then we are getting the value of rectification, or that is also known as efficiency of rectification. Okay, and it is always calculated in percentage, right? So this is second performance parameter. Obviously the first performance parameter was rectified output power, right, which is PDC is equal to VDC into IDC. So what is ideally expected here? We required more and more power from the converter, right? In second performance parameter, obviously we required more efficiency. Obviously that whatever the converter circuit is there, it must be able to provide you the maximum rectified output voltage, or the maximum rectified output power, right? So percentage efficiency is equal to P0 DC upon POAC into 100. Then next performance parameter, third performance parameter is form factor, which is represented as FF, and basically which is the measure of shape of output voltage, right? So what is this form factor is basically RMS output voltage. It is the ratio of RMS output voltage to the DC load output voltage. And this form factor basically measures the shape of output voltage, right? And this shape of output voltage can be find out with the formula, and the formula or the ratio, it is the ratio of RMS output voltage. We can observe here RMS output voltage, it is the ratio of RMS output voltage to the DC load output voltage, right? If we take the ratio of both these, then definitely we are getting form factor, and from this form factor we can measure the shape of output voltage, right? But to find out this form factor, we require two values. First is RMS output voltage and another is DC load output voltage. Once we know DC output voltage, we can find out the RMS value from this value, from this VODC. Okay, so we can find out form factor. The next important fourth performance parameter is ripple factor. Fourth performance parameter is ripple factor. Now, what is this ripple factor is basically? It is basically under root form factor square minus 1. Okay, form factor square minus 1, or it can be written as VAC upon VDC. So this is the fourth performance parameter. Okay, VAC upon VDC. Whatever applied, if we take the ratio of applied voltage to the output voltage, then definitely we are getting ripple factor, right? And this ripple factor indicating the presence of AC quantity in the DC. Whatever output voltage we are getting after converter, these output may contain some kind of AC components, right? And this presence of AC component in the output voltage will be represented mathematically by the ripple factor. So it is VSC upon VDC. Next performance parameter is current ripple factor. Just like the voltage ripple factor, which is VSC upon VDC, current ripple factor is there, which is IAC upon IDC. Okay, this is fifth performance parameter, ripple factor. The next performance parameter is transformer utilization factor. So what is this transformer utilization factor? It is the output power upon input power. Now what is this? Basically PODC is nothing but output power, and VS and IS will be the RMS supply of applied AC voltage. VS will be the RMS value of applied AC voltage, and IS will be the RMS value of applied AC current. So it is P0 DC upon VS into IS. This is transformer utilization factor. Okay. Then next performance parameter is displacement factor, which is also known as fundamental power factor. In a previous session, we have seen the power factor, the concept of power factor, how we can increase the power factor, right? And what is power factor? Basically, it is the cosine of the angle between voltage and current. That is what known as power factor. Okay. So whatever fundamental power factor is there, it is basically the known as displacement factor as well, and it is basically the cos phi. It is basically cos phi. Okay. The next performance parameter is harmonic factor, or it is also known as total harmonic distortion factor. Sometimes it may called as a harmonic factor, right? Or sometimes it may called as a total harmonic distortion factor. Okay. So what is this? It is HF, that is harmonic factor, is equal to IS upon IS1 into bracket square minus 1 whole bracket raised to 1 by 2. Okay. What is this IS? IS will be the RMS value of applied current, the AC current, right? And IS1 will be the fundamental value of fundamental RMS value of AC current, IS1. Okay. So this is what the RMS value of fundamental component of input supply current. Okay. So this is the harmonic factor. The next is input power factor. What is this input power factor? It is basically IS1 upon IS into cos phi. Okay, what is this IS1? IS1 is basically the RMS value of fundamental component of input supply current. What is this IS? It is RMS value of the input supply current, and this cos phi will be the uh, angle between these two, IS1 and IS. So it is basically known as input power factor, right? The next is crest factor. Last performance parameter is crest factor. Basically, it is the ratio of peak input supply current to the RMS input supply current. Okay, it is the ratio of peak input supply current to the RMS input supply current. So, what we have seen, few performance parameters are there. If we calculate the value for all those parameters, then we can easily analyze the performance of converter. So what is there basically? The first is crest factor. We have seen 8 to 9 performance parameters. In that, the one factor is crest factor, right? One parameter is crest factor. Then next we have seen input power factor. Then next we have seen harmonic factor. Then next was displacement factor. Then next is total utilization factor, TUF. Okay, then next is current ripple factor. Okay, then next is ripple factor with respect to output voltage. Then next is foam factor, right? Then next is efficiency of rectification. Okay, then next is output DC power. So these all are the performance parameters for converter. If we easily find out the value for each and every parameter, then we can judge the performance of that converter circuit. Okay. So these performance parameters are very much important. Why this is so? Because